Hello there, you people. I'm back. It's been a while since we did a video, but I'm here to talk to you about fractions. Our class has been talking about fractions. We've been talking about equivalent fractions, comparing fractions, adding and subtracting fractions, and that's as far as we've gotten so far. This video here is going to be referring to equivalent fractions and comparing fractions. So let's get right to it. In order for you to decide if a fraction is equivalent, which means equal, if two fractions are the same, there are a couple ways you can do that. So let's take these two fractions for instance, 1/4 and 2/8. Now, you can do this with, you can have items. So we can use these things like this, right? We can have, if we had tiles, we could use actual tiles. We can't always use tiles, we don't always have tiles. And so, if you have tiles, it's very clear to see that these things are equal. We're looking for them to be the same length, okay? If you don't have tiles, one of the things that you can do is use multiplication to decide. This is how I've taught my class. What can we do with these two, with this number and this number? Is there some, I should ask it this way, is there something we can do with these two numbers that is the same? Because I've taught my students, whatever you do to the top, you must do to the bottom. So we're looking for a missing factor here. So can we multiply the 1 times something to equal 2? Times blank equals 2. Hopefully in your mind, you're like, yes, 1 times 2 equals 2. Now we've done a 2 up here, so we have to be able to do a 2 down here. Ooh, that's ugly, isn't it? 1 times something, 4 times something equals 8. 4 times 2 also equals 8. What we've done to the bottom, we also did to the top, and it worked. That means that these things are equal. We have equivalent fractions because we've multiplied them. Now, in addition to just knowing that whatever you do to the top, you must do to the bottom, I have explained to my students this. 1/4 times 2 over 2 equals 2/8 because this number here is code for 1. Anytime you have a pie or whatever else you have cut into 2 pieces, how much of the pie do you have? You have one whole thing. So if you have one whole thing, anything times 1 is itself. 6 times 1 equals 6. 13 times 1 equals 13. Anything times 1 equals itself. Same goes with fractions. 1/4 times 1 whole thing, 1, equals itself. This and this are the same thing. These two things are the same. This and this are the same. We have just given this a new name. That's all we've done here. We've given this a new name. So let's talk about another one. This is how we find and solve for equivalent fractions. And that's part of the trick of this unit, is that there are a couple different things that you do with different ones. So let's look here. "3/5 and 4/10. Are these things equal? Well, can we find a missing factor here? Remember, factor is two things that you multiply together to get a product. 5 times what equals 10? 5 times 2 equals 10. Now, whatever you do to the bottom, you must do to the top. Can we multiply 3 times 2 to equal 4? Hopefully you're saying no. 3 times 2 is 6. We cannot multiply 3 times 2 to equal 4. It doesn't work. That means these two things are unequal. They are not equal. They are not the same. These are two different sized fractions. That is how you find equivalent fractions. Now, the next thing that I have been talking to my students about is comparing fractions. Now, once we find something that's unequal, so let's go back. Let's go back to this one. 3/5 and 4/10. Now we're looking to put something in this circle just like we did before. Less than, greater than, or equal to. Now we're comparing fractions. Which one is bigger? We know that 5 times 2 is 10, but that 3 times 2 is not 4. So we know they're unequal. We know we're not going to use this one. That's why I erase it, right? We're going to use one of these, but how do we find that out? If they're not the same, one of them needs a new name. If they're not the same, so if you multiply these and it doesn't work, then you know they're not equal. If they're not the same, one of them needs a new name. How are we going to accomplish that? Common denominators. That's the name of the fraction game. That's how this works. That's what you need to be doing. Common denominators. Creating these things. And the reason for that is because all that does, so here's 3/5. All that does is change your 3/5 into however many tenths there are, because we're going to give this a new name. And so what this does is this changes it from fifths to 10. We're going to change this one. You're going to always try to change the smaller one, the smaller denominator, right? This changes the 5, and we're going to try to change it to a 10. We want these things to match. The way we do that is by giving it a new name. How do you give a fraction a new name? You give a fraction a new name by multiplying it by 1. One whole thing. You can do whatever you want. You can do 2 over 2, 3 over 3, 14 over 14, 21. I mean, anytime your fraction, your numerator, which as you learned in 3rd grade, is how many pieces of the pie you have, and the denominator, which is the total amount of pieces possible, whenever your numerator and your denominator match, that means you've got the whole thing. You got one whole thing. If I cut this into 4 pieces and I've got all 4 of them, I've got the whole thing. That's what this is. So you get to decide which one you want to use. Get it? Which one, the number 1 you want to use. See, I'm on a roll today, people. Just you wait. We're going to use a 2. Because if I use a 2, 3 times 2 is 6. 5 times 2 is 10. That gives me a new name that makes it very easy to see which one is bigger. Which one is bigger? 6/10? Now that I've given this a new name, I can get rid of these. If I cut a piece of pie into 10 pieces and I offer you 6 pieces or 4 pieces, which one are you going to choose? If you're hungry and you like sweets, then you're going to choose 6 pieces. 6/10 is bigger. 3/5 is greater than 4/10. That's how this works. Let's try another one quickly. Let's try another one. What do I got here? 3/4 compared to 7/8. 3/4 and 7/8. Let's check. First of all, are they equal? Because equal is always an option when you're comparing fractions. 4 times 2 is 8. Because I am learning my multiples, I'm learning my multiplication facts. It's really easy to see that. 4 times 2 is 8. 3 times nothing is 7. So I'm confident that they are not equal. I'm not going to use the equal sign. What am I going to do? Match up these denominators. Hopefully in your brain you're thinking, oh, 4 times 2 equals 8. I already said that. So I'm going to choose to multiply this fraction times 1 using 2's. 2 over 2. If I have 2 pieces of a pie cut into 2 pieces, I've got the whole thing. That equals 1. Anything times 1 equals itself. If they're not the same, they need a new name. So this gives me 8 and 6. Now I can compare these two because these are the same. We've given this one a new name. It's easy to see. So what's bigger, 3/4 or 7/8? We know 3/4 is code for 6/8, and 6/8 is smaller than 7/8. So 7/8 is larger. 3/4 is greater than 7/8. This is a quick review of how to figure out and use your brain to understand equivalent fractions and comparing fractions. Thanks for being here. Sorry for that pause. I'll see you next time when we talk about adding and subtracting fractions.